Bismillahirrahmanirrahim. Assalamu alaikum, my dear students. This is your maths teacher, Mrs. Anjum Wasim. I hope you all are fine and safe. I welcome you all to Mathematics Class 8, lecture number 1 of second term. Dear students, we will start our second term with unit number 5. And the title of this unit is Polynomials. It's a chapter from algebra, and this is the first chapter that we are studying from algebra. Previously, we have studied unit number 1, 2, and 3. And these 3 units were from a branch of mathematics called arithmetic. The topics that we will discuss today are algebraic expressions. Then we will discuss about the polynomials, its definition. And after discussing these 2 articles, we will inshallah solve question number 1 from exercise 5A. Now, before going into the details of today's topic, I will very briefly show you what are the contents of unit 5. There is only one exercise in 5A, but it covers so many concepts about polynomials. It covers coefficients, types, and degrees of the polynomials. It will explain us about the operations on polynomials, and we are very much familiar about the operations on polynomials. There are 4 operations: addition, subtraction, multiplication, and division. Either we are discussing something from arithmetic or something from algebra. These are the 4 basic operations that we always deal with. And then along with these concepts, we will see some applications of the polynomials in the form of the word problems in the exercise. So let's begin today's first topic, which is about the algebraic expressions. But before going into the details of algebraic expressions, let's have a recap of some basic terms of algebra that we have already studied in class 7. For example, we have studied about the constants, we should know about them. We have studied about the variables, we have studied about algebraic operations, and we have studied about the coefficients. We know that the constants and variables are the quantities. Constant is a quantity which remains fixed, it never changes its value, and variables are the quantities which can change their values. For example, x, y, z, and all the English alphabets, they can be used for the variables. And constants, the example of the constant, for example, 0, 1, 2, 3, minus 2, minus 4, minus 10, minus 100, whatever. So all the numbers, all those values which do not change their quantity are called the constants. And algebraic operations, I have already told you about the algebraic operations. And the coefficients are those expressions which are multiplied by the variables. In order to understand all these things in a better way, let us look at these expressions. 2x, 5, a sign of multiplication, plus minus sign, division sign, x, minus 11, 0, variables, something written like algebraic operations, y, constants, minus 7y. So coefficients. So what are these things? X and y, they are the variables, right? They are the quantities which can change their values. And minus 11, 5, and 0, they are the quantities which will never change their value. 5 will remain always 5. 0 cannot be replaced by any other quantity. Minus 11 cannot replace any other quantity. So they are the constants, they are the fixed quantities, right? And look, what is written in yellow is division sign, plus minus sign, multiplication sign, and they are called the algebraic operations. And look at the red ones, 2x and minus 7y. Minus 7 is an expression multiplied by a variable, and 2x is also in 2x, 2 is an expression multiplied by x. So 2 is a coefficient of x, right? And minus 7 is a coefficient of y. So all of these things, they are very, very important, and they make the basic components of algebra. So now let's understand what is an algebraic expression. Any algebraic expression could be a constant, any simple constant, for example 5, for example 10, or number 1. It can be stated as an algebraic expression, or simply we can also say that any simple variable, a single variable, well, for example x, y, or z, that can also be an algebraic expression. And there, for example, if in addition to a simple constant and a simple variable, if we combine a few constants and a few variables with the help of some algebraic operation of addition, multiplication, subtraction, or these 4 operations, along with the constants and the variables and with the coefficients, then we can have an algebraic expression. I mean to say that algebraic expression could be a simple constant, it could be a simple variable, or it could be a combination of the constants and the variables. For example, I am showing you an example: 3x square minus 4y plus 5. Here you can see that constants and variables, they are all connected in one expression, and the algebraic operation of subtraction and addition are there, and there are coefficients 3 and minus 4, they are the coefficients. 3 and minus 4 are the coefficients, x and y are the variables, and 5 is a constant. So this is an algebraic expression, and it is a combination of the constants, the variables, the algebraic operations, and coefficients. So you see how an algebraic expression is made. How can we make an algebraic expression? It could just be a constant, it could just be a variable, or it could be a combination of all these things. So in this way we can have an algebraic expression. So we can define algebraic expression in this manner, that an expression in which the variables or constants or both are connected by some algebraic operation of addition, subtraction, multiplication, and division. So this will be the definition of algebraic expression. That algebraic expression is made by the connection of all these things, made by a combination of all these things. It could just be a variable, it could just be a constant, or they could all be connected by multiplication, division, subtraction, addition, right? Now see some more examples, and we are proceeding towards some more concepts about the algebraic expressions. Look at this example. It is just a constant, and I have already explained you that any constant could be an algebraic expression. So it is an algebraic expression in which we are having only one term. Okay? We are focusing on the terms of the algebraic expressions. How many terms are there in each example? In this example, there is only one term. Look at the next one, 2x plus y. It's an algebraic expression, and there are 2 terms in it, right? Look at the third one, 3y minus 4z plus 7. There are 3 terms in this algebraic expression. Look at the 6x plus 3y minus 2z plus 9. There are more than 3 terms. So we can have more terms in any algebraic expression. There could be 1 term, 2 term, 3 term, 4 term, many terms in an algebraic expression. So we can say that algebraic expression can have 1 term, algebraic expression can have 2 terms, algebraic expression can have 3 terms, and algebraic expression can have more than 3 or more terms. Now I will show you the names of the types of algebraic expression with respect to the number of the terms. For example, if we are having an algebraic expression with one term, its name will be monomial. Mono means one. So it will be a monomial monomial algebraic expression. And if there are two terms in an algebraic expression, then it will be called a binomial. And if there are three terms in an algebraic expression, it will be called a trinomial. So we have got three names: monomial, binomial, and trinomial for the algebraic expressions. Now come to the second part of today's lecture. It is about the polynomials. It is very, very important, and for the understanding of this topic, one very important thing is the exponents of the variables in algebraic expressions. They play a very, very important role in the understanding of the polynomials. Look at these examples. The first algebraic expression, 2x cubed plus 5y minus 3. And look at the exponents of the variables. Here the exponent is x and its variable is 3. Exponent is x and its exponent variable is x and its exponent is 3. Exponent is the power of the variable, right? Here the variable is y and its exponent is 1. जब कुछ नहीं लिखा हुआ तो वो 1 होता है. So its power is 1. Look at the second example, 4y minus 2z7 plus 1. Here the variable is y and the exponent is 1. And here the variable is z and exponent is 7. So we can say that all the exponents are positive. And here the exponents, we can see that the exponents of x and z in these examples, they are positive, and the exponent of y are also positive. So all the exponents are positive in these two examples. Now look at some more examples. Here the exponents are not positive. X raised to power minus 3, 2x raised to power minus 3 plus 5y minus 3. Here the exponent is negative. 4y minus 2z raised to power minus 7 plus 1. Here exponent of z is minus 7. So we can say that the exponents of x and z in these examples, they are not positive this time, they are negative. So I have shown you some algebraic expressions in which the exponents were positive, and now I have shown you the exponents, negative exponents of the variables. Now look at the another case, a third case, a number 3 and a number 5. They are constants, and all the constants are algebraic expressions. So what will be the exponent of the variable in the constants? We are discussing the exponents of the variables, exponents of the expressions, exponents of the variables. Here apparently there is no variable. Exponent of variable, here there is no variable. Apparently there is no variable. So we are declaring that exponent of the variable in 3 and 5 is 0, right? So this is the third case that we have seen, that 0 exponents of the variables. We have seen the positive exponent of variables, we have seen the negative exponents of the variables, and we have seen now the 0 exponents of the variables. In order to clarify how it is 0, I will give you an example. For example, let's see the number 5. And number 5 has a hidden variable with it. How? Because I can write 5 as 5 into x raised to power 0. And we know that x raised to power 0 is equal to 1. Any number with a power 0 is equal to 1. So 5 into 1 will be equal to 5. So in this manner, we have a hidden variable in it. So we can say that every constant has an exponent 0 in its variable, right? So we have got this result that every constant is an algebraic expression, and it has a power of the variable 0. one thing, and the other thing is that, so therefore we are drawing some conclusions. Algebraic expressions can have zero exponent of the variable. Algebraic expressions can have positive exponent of the variable. They can have negative exponent of the variable. Now we will see or judge the relationship between the algebraic expressions and the polynomials. I have shown you algebraic expressions with zero exponent of the variable, with positive exponent of the variable, and with negative exponent of the variable. Why I have shown you all these things? इन सब चीजों का polynomial से क्या relationship था? Let's see. A constant 7, an exponent of the variable in any constant is 0, so 7 के साथ भी exponent of variable 0 होगा. 7x raised to power 5 plus 3 is another example. Exponent of the variable is 5, which is positive, right? So the exponents of the variables are positive. I will declare these two examples as polynomials. I have not explained you the definition, but I am telling you that 7 and 7x raised to power 5 plus 3 is these are the two examples of the polynomials. But on the other hand, 1 over x square, which can be written as x raised to power minus 2, and 7x raised to power minus 5 plus 3, they are having negative exponents, so they are not polynomials. So here we have a comparison. These are the two examples of polynomials, and these are the two examples of non-polynomials. Here the exponents are negative, and in both these cases the exponents are negative, and in both these cases they are 0 and positive. So we get a definition of the polynomial, that polynomial is an algebraic expression with one or more terms in which the exponent of the variable could either be 0 or a positive integer. Here it was 0 and here it was a positive integer. क्या नहीं ये हो सकता? पॉलिनोमियल में एक्सपोनेंट जो है वो वेरिएबल का वो नेगेटिव नहीं हो सकता, अदरवाइज वो 0 भी हो सकता है और वो पॉजिटिव भी हो सकता है. दिस इज अ वेरी वेरी इंपॉर्टेंट कॉन्सेप्ट. इट्स द बेस ऑफ द होल ऑफ द अलजेब्रा. पॉलिनोमियल्स क्या होते हैं? पॉलिनोमियल्स ऐसे अलजेब्रिक एक्सप्रेशंस हैं जिनमें एक्सपोनेंट्स ऑफ वेरिएबल 0 भी हो सकते हैं और पॉजिटिव इंटीजर्स भी हो सकते हैं. और इंटीजर्स हमें मालूम है इंटीजर्स क्या होते हैं, 0 प्लस माइनस 1 प्लस माइनस 2 प्लस माइनस 3 प्लस माइनस 4 सो ऑन. उसमें से पॉजिटिव इंटीजर्स कौन से हैं? 1 2 3 4 5 मीन्स नेचुरल नंबर्स, राइट. सो अगर किसी भी पॉलिनोमियल की जो पावर है, एक्सपोनेंट है, वो नेगेटिव नंबर होगा या कोई फ्रैक्शन होगा या समथिंग एल्स अदर देन पॉजिटिव इंटीजर, तो वो पॉलिनोमियल नहीं होगा, राइट. So this is something very very important to understand. So therefore we can draw a conclusion that every polynomial is an algebraic expression, but every algebraic expression may not be a polynomial, right? We have seen so many algebraic expressions, but a few are polynomial and a few are not polynomial. पॉलिनोमियल सिर्फ वो होंगे जिनकी पावर्स, जिनमें वेरिएबल्स के एक्सपोनेंट्स 0 या पॉजिटिव होंगे, और अलजेब्रिक एक्सप्रेशंस जिनमें एक्सपोनेंट्स नेगेटिव भी हो सकते हैं. एंड वी कैन आल्सो से दैट एवरी कांस्टेंट इज आल्सो अ पॉलिनोमियल. ये दो मेन चीजें जो हैं वो इस सेगमेंट से हमने लर्न की हैं. नाउ वी कैन सॉल्व क्वेश्चन नंबर 1 फ्रॉम एक्सरसाइज. Look at question number 1. Fill in the blanks with monomial, binomial, trinomial and polynomial. We are given certain algebraic expressions और हमें उसमें ये बताना है कि polynomial ये expression monomial है, binomial है, trinomial है या polynomial है. Look at this. There is just one term, so it is a monomial. 2abc. इट इज जस्ट वन टर्म. इनके दरमियान में कोई माइनस या प्लस नहीं है. माइनस और प्लस साइन से टर्म्स सेपरेट होती हैं, राइट. अब ये इसके दरमियान में मल्टीप्लाई का साइन है, इसलिए मल्टीप्लाई का साइन से टर्म सेपरेट नहीं होती. किसी अलजेब्रिक एक्सप्रेशन में ये एक ही टर्म कहलाएगी. अगर ये होता 2a प्लस बी सी, 2a माइनस बी सी या 2 प्लस a प्लस b प्लस c, तो ये टर्म्स ज्यादा होती जाती. अब ये एक ही टर्म कहलाएगी. सो इट्स आंसर इज मोनोमियल. Look at this one. Now there is a minus sign. This minus sign is separating the two terms. One term is 3 and the other term is 4a. This 4a is not like ये दो terms हैं. 4 और a क्योंकि मल्टीप्लाई हो रहे हैं इसलिए ये एक ही टर्म है। अगर ये डिवाइड भी हो रहे होते 4 डिवाइडेड बाय a तो भी एक टर्म काउंट होते। 3 एक डिफरेंट टर्म होता और 4 डिवाइडेड बाय एक डिफरेंट टर्म होता। इस वक्त 3 एक टर्म है और 4 एक टर्म है, सो इट्स अ बाइनोमियल। it's a case in which there are two terms. Part C, minus xy plus 2z square. How many terms are there? Definitely there are two terms, so it's a binomial. Part D, ax square plus bx plus c over a. One term ax square, second term bx, and this third term c over a is just one term, right? So it's a case of trinomial. Next, part E, a plus b plus c plus d plus e. There are so many terms, so it's a polynomial, and all the powers are, all the exponents are positive integers. 6a over b minus c square plus 2ab. There are three terms, so it's a trinomial. 2ab plus b minus c plus 1. So there are more than three terms and all the powers are positive integers. And here the power is a 0. 1 की power जो है वो 0 है. Variable का exponent 0 है, so it's a polynomial. And h part 3a over bc square. a की single expression है, multiply भी हो रहे हैं, divide भी हो रहे हैं, but कोई plus या minus का sign नहीं है जो terms को separate करे. So it will be declared as a monomial. Right? I hope it is clear. Now we will see what we have learned. सबसे पहले हमने ये सीखा कि algebraic expressions जो हैं वो किस तरह बनते हैं. They are a combination of constants, variables, coefficients and algebraic operations. इन सबसे चीजों से मिलकर algebraic expressions बनते हैं. फिर हमने ये सीखा कि algebraic expressions जो हैं उनके exponents जीरो भी हो सकते हैं और पॉजिटिव भी हो सकते हैं और नेगेटिव भी, लेकिन जिनके एक्सपोनेंट्स जीरो या पॉजिटिव होंगे वो पॉलिनोमियल्स होंगे. Algebraic expression with exponent of the variable as zero and positive integer are declared as the polynomials. और फिर हमने क्या सीखा कि every polynomial is an algebraic expression, but every algebraic expression may not be a polynomial, right? हर जो भी आप पॉलिनोमियल देखेंगे या आपको प्रेजेंट किया जाएगा वो उसको आप अलजेब्रिक एक्सप्रेशन डिक्लेयर कर सकते हैं, लेकिन जरूरी नहीं कि जो अलजेब्रिक एक्सप्रेशन भी आपके सामने आए वो पॉलिनोमियल हो, क्योंकि हो सकता है कि उसमें वेरिएबल्स के एक्सपोनेंट्स नेगेटिव हो या फ्रैक्शन हो, यानी 1/2 की फॉर्म में हो, जैसे अंडर रूट एक्स है तो ये अलजेब्रिक एक्सप्रेशन तो होगा लेकिन पॉलिनोमियल नहीं होगा. अलजेब्रिक एक्सप्रेशंस कुड बी मोनोमियल, बाइनोमियल एंड ट्राइनोमियल. ये किस चीज पे डिपेंड करती है ये चीज कि उसमें टर्म्स कितनी हैं. अगर एक टर्म है तो मोनोमियल, दो है तो बाइनोमियल, तीन है तो ट्राइनोमियल. फिर हमने क्या सीखा कि एवरी कांस्टेंट इज एन अलजेब्रिक एक्सप्रेशन एंड अ पॉलिनोमियल. ये चीज भी बहुत इंपॉर्टेंट है, नेक्स्ट क्लासेस में आपके बहुत काम आएगी कि हर कांस्टेंट जो है वो एक पॉलिनोमियल है या नहीं है और वो किस तरह है. Algebraic expression can have negative exponents of the variables. ठीक है, इसलिए एग्जांपल्स भी आपने देखी कि उनकी पावर्स जो हैं वो algebraic expressions की नेगेटिव हो सकती हैं. और उसके बाद फिर हमने एक्सरसाइज 5A का क्वेश्चन नंबर 1 सॉल्व किया. और अब हम देखेंगे कि हमारा आज का होमवर्क क्या है. First of all, you will write down the summary of the lecture on neat copy. जो summary अभी मैंने आपको सारी दिखाई है, ये सारी summary आप अपने neat copy पे लिखेंगे. Then you will solve question number 1 of exercise 5A on your neat copy. और एक आपका सोचने का की एक्टिविटी है आपकी. You will have to think and write the answers or answer of the following question on your rough copy or on a sheet. That in question number 1, you have to pick the algebraic expressions which are not polynomials. Now, after the understanding of the whole lecture, you should be able to understand which algebraic expressions are polynomials and which algebraic expressions are not polynomials. So, from question number 1, you will pick out all those algebraic expressions which are not polynomials, and you will assume all the expressions a, b, c, x, y, z, whatever alphabets are given there, you will assume that they all are the variables, right? Thank you, class.